Hello everyone, what is up? I hope you guys are doing well. So today we are going to study a really important chemistry chapter, which is the Hall-Heroult process. And when we divide chemistry into branches, this is basically the soul of what we call metallurgy. Metallurgy is basically the study of extraction of metals, cores, and from their actual cores. And today we have a really important chapter of metallurgy, which is the Hall-Heroult process. If you are in CBSE, ICSE, ICSE 10th, 11th, 12th, doesn't matter, or if you just want to get some general knowledge, this is one process that you should have an idea of. And today we are going to study this in not a lot of detail, but something which will definitely stay up to your knowledge, and you will really enjoy studying this process. And this is actually a really fun topic of chemistry as well. So without further ado, let's start. So what is basically Hall-Heroult process? So Hall-Heroult process, let me first get the name straight, don't get confused by the name. Hall-Heroult are basically the inventors. Like in science, everything is named from their inventors or person who first discovered it. Same goes with the Hall-Heroult process. This is something these two guys invented together. For what? For what? Now we're gonna see. Extraction of one of the most abundant metals on planet Earth. Extraction of aluminum. So we are going to study extraction of aluminum, and basically this is the soul of what we call metallurgy. I hope we can understand this much. And moving further, extraction of aluminum from its ore. And the main ore that we have on Earth for aluminum is bauxite, which has a formula of Al2O3 dot XH2 you can consider, but if I be more specific, then it's 2H2. Al2O3 dot 2H2O is basically what? Your bauxite, which is the main ore for aluminum. And this is where we are going to, revolve our chapter or the topic or Hall-Heroult process around. So this is what happens. So जब भी हम whenever we have to extract a metal from their ore, so like in this case bauxite, first step in getting a metal out from any core is grinding and removing volatile impurities. I'll explain it to you in a second. Come to it. Grinding and removing volatile impurities. I hope you guys are catching up till now. Impurities, grinding and removing volatile. So pardon for my writing, but you guys will have to bear with it. So grinding and removing volatile impurities. What do I mean? Grinding means dividing the core into smaller pieces. Basically, it is done to increase the surface area, so we can work out all of our process of removing that from ore a little bit quicker, which also helps save costs, which I'll explain to you why it saves cost. You can check out my equilibrium chapter if you want to study that. And grinding and removing volatile impurity. So what do we mean by volatile? Volatile is something which evaporates anyway. Like for an example, whenever you apply a perfume, so it goes away, right? For a second it stays in liquid form, but then it immediately turns into gaseous state. That is being volatile. Your perfume is volatile. It evaporates really quickly. So any impurity which can evaporate really quickly is removed from the first step, just to make our work and job a little bit easier and save costs again. Cost is the main thing in all of industry. So any metallurgy you study or any industrial process like the contact or the cable process you will study will be revolving around costs, in saving cost, in how do we get a compromise just to save costs, because the industry always runs on profits and that is why we are all having these processes. So grinding and removing volatile impurities. So when we have done that, we have increased the surface area of bauxite. So we have broken it into pieces, which increases surface area, and we have removed volatile impurities. How? By heating it a little bit, not a lot, just a little bit, so that these volatile impurities can get removed. Second step that we are going to doing is what some people call concentration, or I like to call removing major impurities. Like we remove volatile impurities, but they are not the significant impurities like sand, silica, and a lot of other things present in our earth. So now is a step we call concentration. Really important step, because without this you won't be able to get pure aluminum, which is our main agenda of the whole process. So that won't make sense. So when we have removed impurities, so sorry for that was just my table. So when we have removed these impurities, that is the process in which we call concentration. So this Al2O3.2H2O then becomes what we call alumina, which is the most important material for HEROULT process. Alumina is formed in the process of concentration. Now the process of concentration involves a lot of equations, but I won't go into such detail. You just have to know that first bauxite is mixed with sodium hydroxide to form I think NaLO2 plus H2O. Then that NaLO2 is taken, then it is combined with H2O to form some kind of I think again NaOH 3 something like that, and that ALOH 3 is then finally under high heat temperatures converted into alumina and water, and that is the most important equation of the all three. You don't need to remember what I just said, but just keep it in your mind. So in any case, so I'll add the last equation only. So ALOH cube under high heat, which is around 1000 degrees Celsius, converts into Al2O3, most important alumina. Do you remember this equation? Yes, alumina, most important substance of whole of this process. Really important. Plus H2 is also produced, but in little amounts, and it gets evaporated obviously. Okay, now in let's take any other. If we had to take any other ore and extract a metal other than aluminum, okay, so then the third step would have been converting it into metal oxide. But here's the catch: in aluminum, in HEROULT process, we already have metal oxide, which is alumina, Al2O3. So congratulations, we just missed a step. That means we don't have the need of the typical third step, which would have been conversion of anything into a metal oxide. But since we have already done that in concentration, we won't need that typical third step, and we're going to switch gears to something else. Let's drink water. Okay, so now the third step, the major step, okay, is basically converting this alumina into our pure alumina. Samajh definitely. I hope you guys are getting it. So this Al2O3 is converted into pure Al. In what form? We'll be coming to that in a bit. But what we have to do is remove oxygen. Now, usually that removal of oxygen is either typically done through calcination or roasting, right? Calcination or roasting. You have to, I won't explain it to you right now because it will take a lot of you guys' time. Right now we are here for something else. So Al2O3 is converted into Al, but not through the typical methods of roasting or calcination. Or one of the most typical or major ways in which we remove this is obviously reduction with carbon. But here's the deal. Aluminum oxide is a really strong and stable oxide. So this is a what? Stable oxide. And it has really strong bonds. And that being because of aluminum, which is a really reactive metal. If you guys know the reactive basis, please stop calling me a zebra. So it's above zinc and above carbon as well. That means we cannot reduce it through carbon. So reduction won't work here. And now we human beings came up with a solution of extracting these metals, क्योंकि हमें इन्हें भी तो करना ही होगा ना, जो कार्बन से कम है उन्हें तो हमने कार्बन से रिड्यूस करके इजीली एक्सट्रैक्ट कर लिया. लेकिन व्हाट अबाउट दीज मेटल्स? एंड दीज आर द मोस्ट इंपॉर्टेंट मेटल्स व्हिच आर द रिएक्टिव मेटल्स, मैग्नीशियम, सोडियम, एल्यूमिनियम, पोटेशियम. So these are really important metals. So the way that we do this, so can I write this? I hope you guys have noted down either in your copies or either in your brains, either way. So yes, so now how do we do it? Electrolytic refining. Electrolytic refining, which was given birth through electrolysis. Electrolysis, I hope you guys all understand electrolysis, the breaking down of ionic compounds using electricity. It's based on that only, because that is what we are going to use in intercepting water. Okay, so when we thought of doing electrolytic refining, which is our only option, on aluminum, it created massive problems. Because in this industry, it runs on profits. So aluminum was making it really expensive. Despite Al2O3 being, bauxite being a really abundant core, aluminum was still expensive because this was really expensive. And this was really expensive. What were the problems? Let me get it to you straight. That alumina, Al2O3, is a poor conductor. I'll come to that why it's such a big problem. Second thing is that high costs but low output. What do we mean by that? I'll come to it in a second. High cost but low output. Bad for industries. So industries won't run this way, no? Then aluminum won't be extracted only. So Al2O3 is a poor conductor. Now the whole essence of electrolytic refining is based on electrolysis, and electrolysis performs in only those things which are a good conductor, right? And Al2O3 is a very bad conductor. This would take too much cost to perform electrolysis or electrolytic refining on aluminum, and this is the only way we can extract aluminum. Second problem that arose was high cost and low output. What do I mean? Really high melting point. Now for electrolysis, if you guys have done that course, you either need a aqueous solution or a molten solution. Now we can't obviously do molten because then it will do not make any sense. Then we won't be able to extract aluminum. So we'll have to use a molten solution of aluminum. So but this had really high melting point, over I think 1500 or 2000 degrees Celsius, which was causing a huge problem for industry. The industry said no, that हमें तो नहीं करना है भाई, हम इतना अगर हमें प्रॉफिट भी होगा तो भी हम ये लॉस नहीं ले सकते, क्योंकि this required really high markup costs. I hope economics students can relate or not. Okay, right? So really high melting point. These were the main problems, and these were huge problems because industry was saying no to extracting aluminum. This is exact time when all hand HEROULT. So these guys came up and they said that we'll solve your problems. Just give us some time. So in that time, they discovered or mixed uh, two really important stuff. But for I'm not going to deep, and the second material is you'll have to understand a lot for that. So we're only going to study that one substance which they discovered to solve these problems. They discovered something they called cryolite. Cryolite was basically Na3AlF6. This was cryolite. Cryolite was a substance which not only increased conductivity but significantly lowered down the melting point. It brought the melting point around 900 degrees Celsius and increased conductivity. Okay, so it increased conductivity. Sorry for that great cursive handwriting. So basically, this was cryolite. This is the most important topic or point of this whole process: discovery of cryolite. Na3AlF6. What did it do? It solved problems like it improved conductivity of alumina and the high cost low output problem, which meant that it required really high temperatures to melt alumina and then perform electrolytic refining. It solved that problem because it brought down the temperature, the melting point, significantly, which made industries profit skyrocket, which meant more what? Extraction of aluminum. This made aluminum cheaper in that era, although I don't have any idea of what year this was discovered in. What history sucks, right? I know. Anyways, I hope you guys understood this really important topic. Now you'll be moving for, just bear with me for around 5-6 more minutes, because we are moving to the most important topic, which is the actual process that we are going to use to, electrolytic refine our aluminum. So now right now we have alumina to Na3AlF6 in what? Something we call electrolyte. So if you guys haven't studied electrolysis, please go and study that first. Electrolyte consisted of these two things: alumina and Na3AlF6 are cryolite. This was done in the ratio of 1:3. Okay, so for every one there were 3 cryolites. I hope you guys understand. That's how ratios work, right? So 1:3 ratio alumina is to Na3AlF6. Do remember that important statistic. All the statistics are basically lies. Not this one. Let's move on. Electrolyte. So this is our electrolyte. 1:3 ratio of alumina and Na3AlF6. Now here's what it looks like. Okay. 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 Right. Sorry for that. Right. Right. This is what basically you need to remember. I'll do something important here as well. There we go. This is what the basic structure looks like. Now here's what is important to understand. This is connected to a positive terminal, and these are negative, right? Are these negative or these not negative? Am I right or am I wrong? Are these positive or are these negative? Are these anodes or are these cathodes? These are anodes. That means panic. I hope you guys remember that forever in your life. Positive is anode, negative is cathode. positive, 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 and this is our cathode, this vessel. And don't only this boundary is cathode. Okay, this is not cathode. I don't have a different colored marker, so I'll not do that. This is carbon line. And everything here is made from carbon. Carbon, 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 everything. And we will have a powdered coke here, which will also be carbon. Coke. I'll explain to you what's there. And this is basically our electrolyte. Okay, important stuff. Carbon, 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 everything carbon. This carbon lining, and this is the output. So you can see this slope kind of thing, so that all of the aluminum is extracted from here. Getting the point. Na3LF6 plus alumina. Okay, great stuff. I hope these are the anodes. This is connected to a positive terminal. This is the cathode, this vessel, which has carbon lining here. Got it? Got the point. Okay. One more thing you have to know is that at anode oxidation occurs, which you'll obviously know if you have studied electrolysis. At cathode, reduction occurs. I hope that does make sense till now. If you have any doubts, you can post it in the comments. Right, I'll see to it. So these, I hope you understand the whole process and how this comes out. Pardon the writing again. I can't really improve that. Okay, and then this is heat supply. Heat supply of what? Around 950 degrees Celsius. Because we have added cryolite. If we had not done added cryolite, this would have been absurdly high temperatures. Right? Now, here's what ions are present in this. Ions present. Really important thing, because we'll need to do the whole electrolysis thing, so we'll need it. So think Al3 plus O2 minus. This is from our alumina. Then we'll have Na. Na is what? 2 plus or 3 plus? I think Na is just a plus. And we also have something called F minus from our beloved cryolite. This again. These are the ions present. Because we'll do electrolysis, no? So this is important. Okay. We'll cut to I think I'll keep the diagram actually. It's important. I'll remove everything. And I'll keep the diagram. Okay. Now here's what happens at anode. Anode. What happens at anode again? Oxidation. You're right. When oxidation happens at the anode, what are we thinking at? Well, what is the main equation? What ions are basically going to? So what did we have? Let's just write Al3 plus O2 minus and F minus. That okay. So what something which is less reactive gets displaced at the anode or the cathode, right? So we have two cations and two anions. So एनोड पे कौन सा जाएगा? पॉजिटिव होता है एनोड तो क्या जाएगा? एनायन, नेगेटिव आयन. Because it is positive, so positive negative attract. Okay. So which one do you think will go? Fluorine is way more reactive. It is the most reactive halogen. Oxygen is obviously the less reactive. So what is the basic equation that we follow when you derive equations under anode? it's not a plus. It gets reduced as well. So it's something like O2 plus 2E minus, something like that. Yeah, that is obviously something like that. And that is have to be the correct equation. Sorry if in any lecture I mess up equations. I'm a little weak with that. It's still good. Okay. So what do we do at cathode? Cathode positive ions feel need, right? Because cathode itself is negative. So cations. Aluminum, sodium. Revise the reactivity series. Please stop calling me. So sodium we have already got it at the second position. So it's aluminum. Yes, that is what you need, because you need 3 electrons to get pure aluminum. This is the way you follow when doing equations. This is the whole process of HEROULT. Now we have ended the process. Then we'll just refine this to get pure aluminum. This is the end. Okay, this is the end. But important stuff that we need to remember for now. One important question, no matter what board you are from, is why anode decreases in mass. Any guesses? Any guesses? Obviously this is not a live class, so I won't see your replies, but guess it for a second. Pause the video or something. Right. So I hope you have guessed it by now. Now, or even not, then see. So this is positive, right? Positive. So what is going at the anode? Oxygen, right? Oxygen. Oxygen is going to get displaced at the anode. So, and what is the anode made up of? Carbon. Okay. And what is, produced at the anode? Oxygen. Okay. Carbon plus oxygen, seems familiar? Yes. That is our beloved carbon dioxide. Easiest equation you get, right? C plus O2 makes CO2. CO2 is what? A gas. A gas means it will cause erosion of this carbon. Because carbon can react with oxygen. It is not irreactive carbon, right? So when carbon reacts with oxygen, it goes away in the form of what? Some gas that we call a toxic gas, responsible for all of our, air pollution, carbon dioxide. It's also present here. Somehow carbon dioxide is always there. So this anode will decrease in mass. Got the point. So you will need to change the anode every twice runs, right? So the industry does need to take care of that, and you also, because that will be on your exam. Okay, this is why the anode decreases in mass, because the carbon and oxygen react to produce carbon dioxide. The anode decreases in mass. Secondly, I promise you to tell about why we will throw powder coke here. It's to prevent anode corrosion. Why? This carbon and this is oxygen. So oxygen first attacks the powdered coke. The powdered coke first eradicates in the form of carbon dioxide before the anode does. So it takes a little more time for the anode to decrease in mass. Obviously saving cost, because this would be expensive to make. It just took me around 0.1 rupee pen ink, or I can tell the cost of what ink I used to write. But it obviously takes a lot in industries, because it's something real. This is just drawing. And then we get aluminum left in the electrolyte, pure at the cathode, because this is the cathode, this is the slippery slope, and the aluminum gets pure. Aluminum goes through refining to get pure aluminum. Let's go. We got our metal. Congratulations. I hope you guys got the whole point. And the powdered coke, it also prevents heat loss, because this is closed though. This is probably not closed. So it prevents heat loss, eventually saving cost. So you are getting it. Industries only run for profit. So any process you do in metallurgy or any industrial process like cable contact, you'll see it revolve around profits. And that was it for the whole HEROULT process. Hope you guys liked it, and let's chase that exam together. See you.